Hello and welcome to the fifth session of the Building Safety Act 2022 CPD series provided and presented by the Institution of Structural Engineers. This session is being recorded for reference and sharing purposes. CPD is crucial for structural engineers as it ensures they remain up to date with evolving industry standards, technologies, and regulations. With the introduction of the Building Safety Act 2022, structural engineers must stay informed about new safety protocols, risk management practices, and legal responsibilities. The legislation places a strong emphasis on accountability, transparency, and compliance with safety standards, particularly for high-risk buildings. It introduces new requirements for risk assessment, increased scrutiny of building design, and heightens responsibilities throughout the building's life cycle. This legislation will shape how we approach building safety, requiring a more rigorous, collaborative, and accountable approach in our practice. My name is Human Boghi, and I'm hosting this CPD series as the chair of the Southeast Super Region, comprising 4 hubs as annotated on the map. These CPDs are prepared and presented by the structural engineers within the region. The light purple area on this map shows where we are, who we are, and how we can support our members. For help and support on technical matters, CPDs, webinars, training, courses, and many more, please visit the institution website or contact the HQ. For those who would like to watch the previous sessions, they are available on the institution's YouTube channel highlighted in blue. Session 4 will be uploaded soon. Please note the topics and dates that will be presented in due course. Please book your place soon as the number of the attendees is limited. Please send questions via the text message box, which will be answered either during or after the session. Without further delay, I hand over to Ruth to introduce herself and share her presentation.
Good afternoon. I hope everyone can hear me. Okay, so I'm actually standing in for Chris O'Regan. So you might have come under false pretenses. And I'm also going to thank my colleague, Matt Siverson, because actually this is his presentation that we've delivered to the Eastern regions. So this is session 5 of your series of CPDs on the Building Safety Act. And we're going to be talking about gateways. We're also going to talk about Gateway 2 and Gateway 3 specifically. So my name is Ruth Haynes, and I'm the Associate Director of Structures within Bureau Veritas Building Control. And like I said, this presentation was kindly prepared by Matt Siverson, who is one of the engineers in our team. And at the end, we've actually provided email addresses if anyone wants to email us with more questions. So what we do at Bureau Veritas Building Control is we do our own building control. We are a registered building control approver, because of course not all buildings are higher risk buildings. We also advise people on how they might get through a Gateway 2 application. But key to our role, and this is one of the reasons why we're speaking today, is that we are in the framework with the Building Safety Regulator. So we check a lot of projects that have been submitted to the Building Safety Regulator for a Gateway 2 application. So we have quite a bit of experience in how the process is working and what we find out during our checking procedure. Okay, so I'm going to start with the statutory framework. Of course, we all know that there's a Building Safety Act 2022, and this is probably the most significant change to the regime in the UK of recent years. And I think it's becoming increasingly evident that a change of regime was required. So the Building Safety Act enabled the creation of the Building Safety Regulator, which I'll refer to as the BSR. And the Building Safety Regulator has taken over the function of building control for higher risk buildings. So a higher risk building is a building that's at least 18 metres in height or at least 7 stories and contains at least 2 residential units or is a care home or a hospital. There's a bit of a caveat at the end of this slide because there's another stage in the life of a building, which we as engineers often forget about, and that's the in-occupation stage, when people actually live in these buildings. So there are slightly different rules around different types of buildings, whether they're in the process of being built, completed, or whether they're in occupation. And I'm not going to go into the detail of this in this talk. But I would like to say a bit about why we concentrate on residential when it comes to the Building Safety Act. And I think it's because, well, I know it's because a building that contains lots of different households is not really a managed building. You could potentially have 50 different families doing 50 different activities in the privacy of their own homes. A building such as a hospital, a building such as a hotel is a managed building. You have guests, generally 1 or 2 people in a room. There isn't really privacy. Those rooms can be inspected and managed, and you have staff often 24 hours a day. So a residential building with multiple home units has a very different kind of way it's being used and different risks to something like a hotel. Okay, just a few slides to remind us what of a higher risk building is. So actually not actually that tall. Of course, we have the Building Safety Act, but under the Building Safety Act sits lots of secondary legislation. And it's this statute, the Building and Buildings England, that sets out how we do building control. So with a new higher risk building, as an engineer, you'll be contributing towards the submission for building control approval to the building safety regulator, who will then grant approval for that work. And then, of course, you then notify the regulator the day that you would start work, and during the process of being built, there will be inspections by structural engineers or fire officers or registered building inspectors. But of course, not all HRBs are brand new. Many HRBs are existing buildings, and this Act also covers work to existing higher risk buildings. So let's talk about the gateway process. So the gateways roughly align with what we're used to in terms of planning building projects in the UK. So Gateway 1 is effectively prior to planning permission, where applicants will demonstrate that their planning application records thinking on fire safety. Gateway 2, this is prior to construction, and these are the submissions that we're currently looking at. A Gateway 2 application is you provide your design information to the regulator for approval, and you cannot start on site until you've got approval for your scheme. This is quite a significant change to UK construction, because we are used to sort of designing as we build, and people are being caught out by this. And you will see on LinkedIn quite a lot of frustrated people. But the intention is, and you won't get through the gateway, is that you provide a full design package demonstrating compliance with the building regulations. And then Gateway 3 is prior to occupations. This is another hard stop in the process. And once the BSR are happy, you'll get a completion certificate. So this isn't dissimilar to building control historically and building control for non-HRBs, in that buildings cannot be occupied until there's a completion certificate. Of course, we're possibly coming out of the end of this to some extent, but there's always a transitional period between old legislation and new legislation. So there are works, higher risk buildings that were started on site and were sufficiently progressed that they were allowed to continue under the old regime. Other projects that hadn't progressed as much or hadn't been notified to a building control were handed across to the building safety regulator to act as building control. So there are buildings out there, higher risk buildings, that are currently being built and are still with the original building control providers, or there's buildings that have switched from the original provider to the building safety regulator. Now, of course, not all building design goes entirely smoothly, and there's often changes. So once you have your Gateway 2 permission, if anything changes that's considered a major change or a minor change, one notifies the building safety regulator. Because we're sort of at the beginning stage of this process, we haven't been dealing with many major changes because quite a lot of the projects that we have been reviewing for the regulator haven't started on site. Now, what hasn't quite been tested is what a major change means. The statement, a change to the structural design or structural loading of the building, does cover an awful lot of things. Interestingly, the one major change I've looked at was a beam going into an existing higher risk building, and the contractor wanted to splice that beam to get it in, and that was considered a major change. So that's just something to bear in mind. That's an example of quite a simple project. It was a wall being removed in a higher risk building. Contractor wanted to splice it, and it had to go back through the regulator as a major change. So possibly design engineers should be thinking about the questions that might be asked and how structural works and alterations are actually progressed so that they can design in things like this. Obviously, anything that counts as a change accumulates time in the construction period because it has to go back through the regulator. Okay, so let's talk about submission requirements and recommendations. So this is a list of the expectations for Gateway 2. So you're expected to provide plans, a competence declaration, so that's a bit new to many people, a construction control plan, which is how you intend to build your building, a change control plan, how you're going to deal with change on site, a mandatory occurrence reporting plan, and a building regulations compliance statement, where you tell the regulator how this building complies with the building regulations. A fire and emergency file. There might be occasions when a partial completion strategy is applicable, and also if a staged work strategy is applicable. So I'm just going to talk about staging a bit. What we mean in the world of the regulator by a staged project is not staging information. It's if a project really is a project that's so large that the construction will be staged. So an example of this might be a very large development with a big podium where multiple towers are going up and the construction period is many years. That could be counted as staging. What we don't mean is staged information. So one day we'll submit some part information, another week we might submit some drawings, another week you might submit calculations. This discussion of staging applies to very large projects. So the Gateway 2 application is the beginning of creating the golden thread for this project. And what we know historically is that often we don't know very much about existing buildings, whether HRBs or not. But the Building Safety Regulator and the Building Act wants people to have a golden thread for a building so that people understand how the building was built and what was then done to the building at a later stage. So if a building is 20, 30, 40 years old, there are no mysteries as to what has happened. So the submission to the Building Safety Regulator, if you're a structural engineer, would include your structural drawings, your reinforced concrete design intent drawings. So note what we say, they're design intent drawings, so not reinforcement drawings. Steelwork design intent drawings with connection forces. And there might be some typical and special detail checks that you want to provide as well, if there's anything unusual going on. The actual reinforcement drawings and steelwork drawings, fabrication drawings, and detailed connection design would be expected at Gateway 3. And what we mean by a design intent drawing is more than an output from software. It is the old-fashioned style design intent drawing that someone can do the detailing for and that a checking engineer can interpret. And then, of course, you'd expect to see the specifications with that package. We've made a note at the end of this slide to read some guidance on what should be included in a Gateway 2 and 3 application. And this reference 5, is actually the iStructure guidance. So right at the end of this presentation, we'll have all our references up. So there is guidance out there for people to follow. Okay, so the competence declaration would also go into a Gateway 2 package of information. And this is where you as a design team should be stating your competence. As most of you are probably aware, there is a new register for structural engineers who work on higher risk buildings. And the register is a joint register with the iStructure and the ICE. And this register, at the moment, it's not a compulsory register, but it's a way of demonstrating that you have competence. And you can apply for this register now. It was launched about a month ago. And you demonstrate competence to go on this register by demonstrating how you have attributes that demonstrate that you can work with the competencies set out in the Engineering Council's Structural Discipline Annex for higher risk buildings. So that is one way of demonstrating competence. Of course, another way of demonstrating competence is to be competent. And as someone who checks lots of design, we can judge an element of competency from a package of information. So if there was a disconnect between someone being on the register, for example, and preparing a poor package, we would have a few questions. The construction control plan is also something that is as a new part of a building control submission to the building safety regulator. And structural engineers should be contributing to the construction control plan. Now, of course, some of the buildings that go through the regulator are significant buildings. And we'd expect to see the design structural engineer setting out an appropriate inspection regime for that building. So in Eurocode 0, there's discussion of design supervision levels and inspection levels, which are compatible with consequence classes. And I would encourage people to read what is required and what is an appropriate inspection level. And then, of course, you as an engineer know where there might be key bits of structure that are higher risk than others. So as you're probably aware, transfer structures are higher risk structures. They take large loads. Often the design is poor. And again, we would encourage people to read the iStructure guidance on the design of transfer structures. So if you are designing a building with a large transfer structure, you might want to increase your inspection levels there as an engineer. So this is the kind of thing that you would put in your construction control plan, or at least you would contribute to. So the building regulations compliance statement, there's lots of building regulations and there's lots of approved documents. And as a structural engineer, it's approved document A that we are mostly worried about, and also approved document B, fire. But A is relatively simple. We have A1, A2, and A3. How does the structure support loading? How do we transfer the load to the ground? And how do we avoid disproportionate collapse? So we would expect to see the compliance statement to address how those issues are being dealt with. And the statement obviously needs evidence, and that evidence would be in the form of calculations. So you might make statements as to how you're demonstrating compliance, and then you might point the building safety regulator in the direction of where they would find that compliance, i.e. which drawings, which calculations, etc. And then the fire and emergency fire, again, it's another new thing that wouldn't have been in a traditional building control application. But the fire and emergency file is another thing that needs to be submitted to the regulator. And as a structural engineer, your contribution would be to do with robustness, because fire is an accidental load, and a description of the fire protection measures. And it might be something that you work up with the fire engineer. But fire and structure are intertwined, and we need to be aware of Part B, even if we're a structural engineer. So in the building control world, we talk about Cat B and Cat A works. Of course, high risk buildings have multiple households. Often the building is set up as a freehold with multiple leaseholders, and sometimes those leaseholders, or sometimes the buildings are tenanted, or sometimes a leaseholder is renting out their flat to a tenant. But category B basically means works that are happening to a residential unit within a building, and category A is works that are communal, effectively. Many of the works that are going on with category A at the moment are recladding works. People are removing the flammable cladding and replacing it with non-flammable cladding, and of course that involves a building control application, the building safety regulator. Okay, you're probably aware in the press that there's many projects that are not getting through the regulator. In fact, there was stuff on LinkedIn over the last few days. We're going to talk about some of the reasons projects are being rejected. This is based on sort of our own knowledge and a few freedom of information requests that there have been. And this will be useful to inform your design. Okay, so this is a summary. So this data is from a few months ago. And if you've been on LinkedIn recently, you'll realise that there's more summaries out there from yesterday. But at the time of putting this slide together, there had been 144 Gateway 2 rejections. And you can see that just less than 20% were because of structure and just over 50% were because of fire. The numbers might be higher, of course, for structure, because sometimes a rejection went out on one thing before, say, the structure had been reviewed. But you can see that fire and structure are absolutely key to a successful Gateway 2 application. So if we break it a bit down, and again, this is from those 144 projects. So the reason for the rejections on structure, 30%, was because of structural calculations. 7% was because of pile design. And that's something that I've experienced, is that the pile design wasn't provided. Now, of course, we're very used to, in the past regime, of the pile design would be done once a piling contractor had been appointed. But that isn't how we work now. The pile design needs to be done before the Gateway 2 application. So delving into these reasons a bit more, often for the structural calculations, there were insufficient calculations to demonstrate design to Eurocode requirements. I mean, insufficient can mean a number of things. Of course, it can mean incorrect or just absent. We often do see things that are incorrect when we check design information. External walls is an interesting one. Again, if you're a consulting engineer, often you're used to designing the facade if it's at a later stage. But again, for Gateway 2, the expectation is that the facade is designed when you make that application, whether it's masonry with an SFS inner skin or curtain walling. That design needs to be in place before the Gateway 2 submission. Quite often we see a bit of brick design, but often not the SFS inner skin, because again, that person hasn't been appointed. I can see that there's a few questions coming up, but I'll address those a bit later on. Another reason for rejection is there's an expectation that the subcontractor will design various bits and pieces. And again, that is likely to be the case, but the point is that that subcontractor design needs to be on board before Gateway 2 approval is given. Okay, keeping going on reasons for rejection, 11% disproportionate collapse, often contradictory statements. We quite often see the consequence class of a building changing throughout a set of calculations, or statements that there's key elements, but then we don't see that the key element has actually been designed. One thing I pick up on quite frequently is that people often forget to calculate their tie forces and demonstrate that either reinforcement or connections, if it's steel framed, have capacity for those tie forces. I've covered the pile design. It is expected that a pile design is provided. I can see one of the questions is a preliminary pile design sufficient? Well, you could submit that. That's better than nothing. But of course, if it's preliminary it changes, then that's a major change. You'd be going back to the regulator. So we would suggest that you might not want to put in a preliminary pile design. Loading is another issue. Wind loading is often not in sufficient detail, or if the shear core for the building isn't in the centre, we quite often see that has been ignored in the wind calculations. Funneling effects of wind have been ignored in calculations, and some of the stuff that are on this slide is actually just often mistakes or omission. Columns have been designed as axial only members. Again, that's quite common. Quite often moments seem to be ignored in design. So again, these pitfalls are a mixture of incorrect design or omitted design. Again, another question on could you submit a preliminary design? You can always submit a preliminary design, but if you change anything, you'll have to go back and request a change, which will slow down the process. Okay, so some easy wins on making it, on putting together a good package. If, of course, a package of information is easy for the checker to read, it makes it a lot easier for a project to be checked. So I would encourage people to present their calculations such that they're readable. A good introduction, a good contents page, a good index, and tell a story. Tell a story about how this works. What I'm often surprised by when I check calculations is that people don't hyperlink between index pages and actual calculations. And I would encourage, this is a very specific thing, I would encourage people to hyperlink between calculations. So if you say the disproportionate collapse strategy is on page 15, link to page 15 so that the checker can find it. If punching shear is buried 4,000 pages into the calculation package, link to that punching shear calculation in your index. And then you could also link to your key drawings. Of course, there is a limit to how big a package can get. Use images as well to explain things. So one of the questions is, what are the expectations for projects where the majority of the analysis and design have been carried out using software? Well, you can demonstrate what you've done with some key examples. Say what you've done, how you've modelled it, include some images of the model, include any description of the limitation of the model. Quite a lot of engineers do this. They give extracts from the model, the relevant extracts. So the extracts showing the loading, how the loading's been applied, extracts showing typical column loads. So there's ways of presenting everything. But of course, the longer the package of information and the more complex it is, the more it costs to check. And that check gets charged to the client. So as a structural engineer, if you can get a reputation for providing detailed but easy to check packages of information, I'm sure that you would be very popular. Then I would also say use appropriate guidance documents. So the iStructE and ICE have quite a lot of guidance. People will have seen the November guidance on transfer slabs. Interestingly, the building safety regulator actually asked us to confirm as a team that we had read that guidance and that we were checking that design engineers were applying that guidance to their design. So I would say that if you're designing transfer structures and you're not following that guidance, that puts you in a difficult situation, because we have been asked to check that you're taking the guidance into account. There's other guidance documents. So the ICE has a good guidance on what to put into a building control submission, which is actually still relevant today, even though it's actually now quite old. And I would encourage people to read that. In fact, I'm contributing with someone at the moment to put out more guidance on what should be included in a building control package. Okay, when this presentation has been done before, we found there's been a lot of questions, but I'm just going to talk about some of this recommended reading. So earlier on in the presentation, when I was talking about the construction control plan and the level of checking that you might do on site, we would encourage you to read the Institution of Structural Engineers Reliability, the Practical Application of Eurocode, which covers design supervision levels and construction supervision levels. The next recommended reading is HSE, Building Control, an Overview of the New Regime. Then for those people who are thinking on demonstrating competence by applying to be on the competency register, we'd encourage you to read the Engineering Council Structural Discipline Annex for higher risk buildings, which was actually put together, I believe, by David Colmy and Chris O'Regan, who was intending to do this talk today. And finally, I'm going to highlight that we've highlighted this document. The Institution of Structural Engineers put out a document called Structural Submissions for Higher Risk Buildings under the Building Safety Act, Guidance for Gateways 2 and 3. And this is actually what we base our checking on. So the discussions on reinforced concrete full detailing versus reinforced concrete design intent drawings, we go with what has been set out in this document. So anyone who puts in a submission should be reading this Institution of Structural Engineers documents. Okay, so I've put in our contact details if anyone wants to speak to me or my colleague Mats afterwards. These are our email addresses. In summary, I would say think about your readership. If we're checking a project and we see errors or even fails, which we often do, we're going to be a lot more suspicious of a design than a design which is nicely presented, tells a story and makes sense.